All right, we're going to start the last section of Investigation 10A by talking about coral reefs and coral bleaching. The coral reef is an example of a marine ecosystem. If you are unfamiliar with a coral reef and what they look like, Unit 9, Lesson 4 has a great picture at the beginning of the lesson. Let me see if I can find it. Okay, so this is the beginning of Lesson 4, and you can see this is a coral reef ecosystem. Very colorful. There's lots of different forms of life in a coral reef ecosystem. All right, so, and that brings us to the next sentence. It says, coral reefs form some of the most diverse ecosystems on Earth. While occupying less than 0.1% of the world ocean surface, they provide a home for a quarter of all marine species. So you're talking about a very, very small area of the ocean, but you're talking about 1/4 of all of the marine species that we find. So there's a whole lot of biodiversity associated with coral reefs. Okay? All right, so make sure that you highlight the two sentences that I highlighted. And also, I just put a little arrow and I reminded myself that when we say that it's a very diverse ecosystem, we say that there's lots of biodiversity. There are lots of variety of living forms, both producers and consumers, that are associated with these coral reefs. Okay, let's go on to the next paragraph. Coral reefs occur mainly in shallow tropical ocean waters within 30 degrees latitude of the Earth's equator. They are among the most productive of all marine habitats, producing 2,000 decagrams of carbon per square meter per year. Coral reefs provide many benefits to humans, including fisheries, coastal protection, tourism, and medicines. I'm not sure if you're aware or not, but there are many medications that come naturally from both marine plants and animals, land plants, things like that. Okay? All right, coral reefs are an accumulation of calcium carbonate deposited by living coral animals over thousands of years. Living coral consists of colonies of small polyps that have zooxanthellae, a type of algae, within their tissues. The presence of pigments associated with the zooxanthellae give the otherwise nearly colorless corals their strikingly colorful appearance. While corals also feed on zooplankton, which is plankton that's more animal-like, as opposed to phytoplankton, which is more plant-like. While corals also feed on zooplankton, they receive energy and oxygen from the zooxanthellae via photosynthesis. Zooxanthellae, which is the algae within them, also promote growth of the reef by aiding in the production of calcium carbonate, which is, remember, the mineral that is used to build the coral reefs. Okay, so this is a mutually beneficial or symbiotic relationship between the coral polyps and zooxanthellae. Okay, so just wanted to point out calcium carbonate is chemically the same substance as you'll find in rocks like limestone and marble. Okay, and I want you guys to, circle the zooxanthellae. And right out to the side, remind yourself that that gives the coral reef its color. Okay. All right. Coral reefs require intense solar radiation, relatively high levels of dissolved oxygen, low turbidity, low nutrients, consistent temperature, and consistent salinity. Remember, salinity is saltiness. Okay. Low turbidity means that the waters are fairly calm. They're not stirred up. Calm waters are going to have less sediment in them. Okay. So calm, clear water. Okay. Now, this whole paragraph right here is talking to you about the abiotic factors required for coral reefs, so make a note of that. Okay, So remember, that whole thing discusses the non-living factors that are important for coral reefs. All right, I'm at the bottom paragraph now. Unfortunately, coral reef ecosystems are under increasing stress and are threatened. Okay, they would be stressed when any of these abiotic factors are not within the limits that a coral reef is used to or has, adapted to. Anyway, a serious threat to coral reefs is coral bleaching, the whitening of coral that takes place when zooxanthellae, the algae, are expelled or killed, impairing the symbiotic relationship with the coral polyps. Most of the color of coral reefs is a result of the zooxanthellae, so that their loss causes the remaining calcium carbonate shell to dominate the coral's appearance. Okay, and if you think about it, bleaching, if you've ever bleached something accidentally in the wash, you turn it white or lighten it. Okay, so basically, if the zooxanthellae are expelled or killed, and remember that the zooxanthellae are what gives the coral its color, and the coral reef otherwise has the color of limestone or marble, it's pretty much going to be kind of white in appearance if you remove the algae. Okay, so just make sure you highlight what I highlighted, that a serious threat is coral bleaching, which is the whitening of the coral that takes place when the zooxanthellae, the algae, are expelled or killed. Okay. And this is a big deal because it impairs that symbiotic relationship. A symbiotic relationship, remember, is a relationship where both parties benefit. So there's a benefit to the coral with this relationship with the algae, but there's also a benefit to the algae being in relationship to the coral. Okay? All right, most of the color of the coral reefs is a result of the zooxanthellae, so that their loss causes the remaining calcium carbonate shell to dominate the coral's appearance, making it look as though it were bleached. The loss of the food supplied by the zooxanthellae leads to coral death. The exact causes of the zooxanthellae death are not completely understood. However, research on coral bleaching suggests that higher sea surface temperatures are a major catalyst, or at least an indicator of coral stress. Okay, what that means is higher sea surface temperatures are going to be one of the things that is going to cause coral bleaching. It's not the only thing that can cause stress and bleaching, but it's one of the major factors. Okay. So just make sure that you've highlighted both of those sentences, the one that says the loss of food supplied by zooxanthellae leads to coral death, and the one that says research on coral bleaching suggests that higher sea surface temperatures are a major catalyst. But also it says coral may be stressed by other environmental factors, including elevated nutrient levels and an increase in turbidity. Okay? Meaning the water is more stirred up. All right, Figure 2 is an example of the National Oceanographic and Atmospheric Association's Coral Reef Watch Coral Bleaching Virtual Stations webpage for the 2nd of May, 2011. Here's what I'm going to do. I am going to move this page so that you can see the chart, and then I will talk you through 21 and 22. All right, so here's the chart. All right, 21 says, examine the data providing information on thermal stress, meaning stress due to heat or increased temperatures, that may cause coral bleaching. Data are provided for locations in what oceans? Well, this column is the Atlantic Ocean, right here. These two columns is the Pacific, and this column is the Indian Ocean. So, on number 21, you have all three of these ocean basins. Number 22, in the Figure 2 table, a red triangular icon signals that some degree of thermal stress is present at a reef site. The table shows that on the 2nd of May 2011, a total of how many stations were experiencing thermal stress to the bleaching watch level. Bleaching watch level means that they've got the little red exclamation point. And there are 1, 2, 3, 4. There are 3 in the Pacific and 1 in the Indian. So that's a total of 4 stations. Okay. This status level of thermal stress, I'm still reading 22, is issued when the current sea surface temperature exceeds the maximum monthly mean sea surface temperature for that station. Okay, I'm going to stop here and I'll do one more screencast to finish this up.